guys, I am Sabana Siddik, Mathabhanga College, 6M. Today we are learning to application of green chemistry to let's start. What is green chemistry? So, environmentally being chemical synthesis which cause least pollution to the environment. We take as follows that green chemistry is all about reducing its first waste to materials 3 hazardous, fourth risks, 5 energy and 6 cost. Today we are studying synthesis of carbonyl synthesis of green chemistry. Under the green principle is safer solvents and auxiliaries and safer chemistry for accident prevention. However, many principles of green chemistry which can be covered in the example of synthesis of carbonyl. The principles are first safer solvent and auxiliaries and second is safer chemistry for accident prevention. According to this principle, the chemical products should be designed in such a way that they have high efficiency and low toxicity. One way minimize the potential for chemical accident is to choose reagents and solvents that minimize the potential for explosion, fire and accidental release. Carbonyl used safely solid commonly solid under the band name 7. This process was carried out in Bhopal by Union Carbonyl where linkage of methyl isocyanate or MIC mishaps took place in 1984, commonly known as Bhopal gas tragedy. First synthesis of carbonyl or 7 and this structure is carbonyl or 7. Now the conventional route. In the conventional route, phosgene is a starting material and it is treated with methyl amine and lone pair on the nitrogen attacks on the carbon of the carbonyl group and Cl is released because Cl is weak ligand. Now this negatively charged chlorine atom attacks on the hydrogen and again the lone pair of the electrons are returned of the nitrogen and HCl is eliminated and we get the product is MCC and MCC is also as known as methyl carbamyl chloride. Now this MCC is rearrangement. The lone pair on the nitrogen attacks on the carbon and Cl is eliminated and this negatively charged of chlorine attacks on the hydrogen and lone pair of the again are returned to nitrogen and HCl is eliminated and we get this product is methyl isocyanate. And this methyl isocyanate is treated with 1 naphthalene. Electrons on the oxygen attacks on the carbon and which is positively charged, the electrons comes on the nitrogen and negatively charged of the nitrogen abstracts on the hydrogen and the lone pair of oxygens are written. Now this product is carbonyl or 7. We are learning to the greener route. In the greener route, 1 naphthalene is treated with the phosgene. The lone pair of the oxygen attacks on the positively charged of carbon. And the Cl is released and this negatively charged of Cl attacks on the hydrogen and the lone pair is returned to oxygen and this now HCl is eliminated and we get this product. And this product it's treated with methyl amine and the lone pair of nitrogen attacks on the carbon and the Cl is released and the negatively charged of Cl, it attacks on the hydrogen, and the lone pair is again returned to nitrogen, and and HCl is eliminated, and the product is carbyl or 7. And next, synthesis of indigo dye. This indigo dye under the principle of green chemistry, that is non-hazardous chemical synthesis. For the current principle presentation, the principle is non-hazardous chemical synthesis. According to this principle, the synthetic method should be designed in such a way that substance having little or no toxicity to humans' health or environment should be used wherever possible. Hence, green chemistry recommends the design of synthesis of use and generate substance with little or no toxicity. Indigo dye is used to color blue jeans. Now this second synthesis of indigo dye, and this structure is indigo dye. First, we see the conventional route for the indigo dye synthesis of green chemistry. For the synthesis of benzene, which is carcinogenic material, is taken as a reactant, and it is then treated with chloroacetic acid. The lone pair of nitrogen attacks on the carbon, and the Cl is released. Now this negatively charged of chlorine attacks on the hydrogen, and that is how Cl is eliminated, and we get this product. Now this product is treated with NaNH2 or sodamide. Sodamide being a strong nucleophile, and it is absorbs water molecule and gives a related ketone product. Now ketone undergoes to ketoenol tautomerism. The lone pair of oxygen attacks on the hydrogen, and thus electrons of the hydrogen bond turn to double bond, and the lone pair of oxygen are returned. And that is how we get in the enol product. Now this ketoenol reactant with this other in the presence of air and oxygen. Now the respected product is indigo dye. Is greener root. In the greener root, L-tryptophan, which is an naturally occurring substance, and it is used as a reactant, and it is treated with tryptophase. The role of this enzyme is to remove side chains, and we get this next product is indole. That is indole. It is treated with naphthalene dioxygenase, and to get this product is dihydroxy product. And this dihydroxy product this treat with oxygen in the presence of air, and it is gives the element its indigo dye. And this indigo dye using unnaturally occurring substance which is non-carcinogenic and the used non-harmful for human being and also for the environment. Thus the greener route is best route compared to the conventional route. Third, synthesis of preparation of 2-cyano-3-phenyl acrylic acid ethyl ester. In the conventional route, we are taking this benzyl alcohol and it is treated with this product in the presence of piperidine and toluene, and we are getting this product. Now in the greener route, be replaced by the KSP, piperidine replaced by the KSP, and toluene replaced by the H2. KSP is catalyst in the section, and water is a green solvent, and we get this product same molecule. Therefore, two method, conventional route and greener route, which is the best method. Green method is better because piperidine is toxic natural and it is not eco-friendly and it is affected to human skin. Toluene is not also be eco-friendly solvent, but water is better solvent of green method. So green method is best. Of benzylic acid synthesis. In the conventional route, this reactant is starting material is treated. This is KOS and ETOS, and we are getting to product is benzylic acid. But in the greener route, this benzyl is treated with solid KOS, and then this mixture is crushed to mortar. And then minimum water plus for the conical flask, and the water bathing of the mixture is at 15 minutes, and then cool and then filtered, and the last of product is benzylic acid.